Hello everyone. On this video we will cover using properties of logarithms. Okay, so now a quick review on our properties of logarithms. If you remember, our log base b of m times n equals log base b of m plus log base b of n. And that's your product rule for logarithms. Okay, now if you have log of base b of m divided by n, that's going to be log base b of m minus log base b of n. So you're just going to subtract when you're dividing. And that's your quotient rule for logarithms. Okay, and last but not least, if you have log base b of m to the power of p, you're going to get that exponent and just bring it down to the front. So you have p times log base b of m. And that's your power rule for logarithms. Okay, so we're going to basically use those to manipulate certain expressions. Alright, so if you are still writing, by all means, feel free to press pause. But we're going to go ahead and go to our first example. Alright, let me bring my paper down. Okay, so let's say, for example, we want to expand the logarithm. Let's say log base 3 of 4x to the 4th power y to the 8th power. Let's see if I can focus that a little bit better. Alright. Alright, so to solve this one, I'm just going to go ahead and rewrite it. So I have log base 3 of 4x to the 4th y to the 8th. If you notice, everything in here is being multiplied. So that means we're going to apply the product rule. But here we have 3 factors. Okay, so if you have 3 factors inside of here, let's say you have log base b of m x z. Okay, then that's going to equal log base b of m plus log base b of x plus log base b of z. So it doesn't matter how many factors you have in here, it's still just going to be added. Alright, so let's go ahead and we're going to rewrite this as log base 3 of 4 plus log base 3 of x to the 4th power plus log base b of y to the 8th power. Alright? Okay, so that's all we can do with the product rule. Now if you notice, a couple of these have exponents. Okay, so if you note here that 4 is equal to 2 squared. Okay, so there are a couple of ways you can write this, and I'll show you both ways to write it. Okay, x to the 4th, you can actually bring down the exponents. So for these two, we can actually apply the power rule. Okay, let's go ahead and move that up a little bit. So if we apply the power rule, that means you have log base 3, and I'm just going to leave that as 4 for right now. Because remember, we can write it another way using that. Okay, here we have our power rule. We're just going to bring that 4 out to the front. So plus 4 times log base 3 of x. And same thing here, we're just going to bring that 8 down to the front. Plus 8 log base 3. Why did I put log base b? I meant log base 3. Clean that a little bit. Log base 3 of 8. Okay, so plus 8 log base 3 of y. Alright. Okay. Now the thing is, this is one way your answer could look. Okay. Now another way it could look is, remember, if we rewrote that as log base 3 of 2 squared, because remember 4 is equal to 2 squared. So if we have log base 3 of 2 squared plus, and remember applying the power rule, well, let's just leave it like that for now. Let's say log base 3 of x to the 4th plus log base 3 of y to the 8th. Okay, we can actually apply the power rule to all of those, not just those two like we did for this answer. So if we rewrote that, bringing that 2 out in front, we have 2 log base 3 of 2 plus 4 log base 3 of x plus 8 log base 3 of y. Okay, so actually these two, it's the same answer, just written 2 different ways. Okay, so if you had, let's say, log base 3 of 36, you could write that as 6 squared and bring the 2 down to the front. So things like that, you can kind of simplify it even more. So same answer, written differently. Uh-oh, here we go. All right. Okay, so if you're still writing, by all means, feel free to press pause. But we're going to go ahead and go to our next example. Alright, so let's say, for example, we want to expand the logarithm and we have log base 4 of square root of x divided by 16y to the 4th. Alright, so before we get started here, one thing you want to remember, that square root of x is equal to x to the 1/2 power. Okay, so we could actually rewrite that numerator. So what we're going to do is just that. So we have log base 4 of x to the 1/2 power divided by 16 y to the 4th power. Okay, now the first thing you're going to notice is the fact that this is division. Okay, so we're going to apply the quotient rule. Quotient rule for logarithms. Remember, that's log base b of m divided by n equals log base b of m minus log base b of n. Okay, so we're going to go ahead and apply that quotient rule, which means if we do that here, it's going to be log base 4 of x to the 1/2 power minus log base 4 of 16y to the 4th power. All right. Now here, of course, we have our power rule we can apply here, but before we do that, we're going to first look at this one. Okay, notice here, you have multiplication. You have 16 times y to the 4th. So use the product rule or multiplication rule, depends on how you want to say it. Okay, so use the product rule for logarithms. So that means we have log base 4 of x to the 1/2 power. And again, if you want to use the power rule first for that one, you could. I'm just kind of focusing on one term at a time. Okay, so minus, now remember, this entire thing is what you're subtracting. So once you apply the product rule, which is log of m times n equals, well, that should be log base b of m plus log base b of n. So once we apply it, this is going to be minus log, I'm running out of pencil lead here. Clean that up a little bit. Okay, so minus log base 4 of 16 plus, let me kind of separate that, log base 4 of y to the 4th. Probably could have had a little more room there, but hopefully it won't get too congested and confusing. Okay, and remember, this right here was just that. So that minus applies to this, and so that means it applies to both of those also. Okay, so if we go ahead and distribute that minus sign, because remember it's like multiplying it by -1, we have log base 4 of x to the 1/2 power minus log base 4 of 16 minus log base 4 of y to the 4th. Okay, so that's why you want to be really aware whenever you have a subtraction, because once you have a subtraction, most of the time those signs will change. So you want to be really conscious of that. All right. Okay, and the reason I just held off on you applying the power rule here is because once you're all done here, because if you note that this can actually be simplified. Because you get just this term, you have log base 4 of 16 equals y. And remember, b to the power of y equals x. So that's 4 to the power of y equals 16. And remember, 16 is just equal to 4 squared. That's 4y, 4 to the power of y equals 4 squared. So the bases are the same. So that means y has to equal 2. That means this entire term is equal to 2. All right, so that gives us, once we apply the power rules, to both of these, and that will give us, that 1/2 comes down to the front. So you have 1/2 log base 4 of x minus 2 minus 4 times log base 4 of y. Okay, so that would be your final answer. So again, you just have to look out for those little rules that you learned along the way. It definitely helps. All right. So if you're still writing, feel free to press pause. We're going to go ahead and go to our next example. All right, there we go. Okay, so let's say, for example, we want to expand the logarithm. Let's say we have log base 7. Okay, and let's say you have the 7th root of 2x y to the 4th power over 11z to the 6th power. All right, so before we get started, we want to remember that, let's say, the 7th root of x equals x to the 1/7 power. Okay, now the reason that's important is because if we start off with log base 7 of the 7th root of 2x y to the 4th power over 11z to the 6th power, we can just rewrite it as log base 7, and instead of the 7th root of that entire thing, we can write it as 2x y to the 4th over 11z to the 6th to the 1/7 power. Okay, so all we did was take the 7th root and then just make that to the 1/7 power. Okay? So now we just apply the power rule. All right? So if we apply the power rule, that 1/7 just goes down to the front. So that gives us 1/7 times log base 7 of 2x y to the 4th over 11z to the 6th power. Okay? Now the first thing we're going to look at after that is the fact that this is division. Once we see that this is division, we apply the quotient rule. Apply okay. Now once you apply the quotient rule, this now becomes 1/7, and this is where it comes in handy to actually put parentheses or brackets or something, because it's 1/7 times, you're just going to convert this, so you have log base 7 of 2x y to the 4th minus log base 7 of 11z to the 6th power. Okay. Now some of you are probably asking, is it okay if I just have the 1/7 to both of those? If you want to have 1/7 log 7 minus 1/7 log 7, you could. I just put the 1/7 over here. Just for me, it's a little bit easier, but you could definitely have it at both of those terms if you wanted to do that. All right. Now here, if you notice, each of these are multiplication. So we're going to apply the product rule. Inside of there. Okay. So that means we have our 1/7 times, actually I might get my, that should still fit. We have log base 7 of 2 plus log base 7 of x plus log base 7 of 4, or 7 of y to the 4. So we have log base 7 of 2 plus log base 7 of x plus log base 7 of y to the 4th. So we have that. So this is expanded to this minus, we have log base 7 of 11 plus log base 7 of z to the 6th power. Okay. So all we did was get this term here and expanded it to this, and this term here, we expanded it to that. Okay, both using the product rule. Okay, and again, whenever you have a minus, you want to be really careful because that minus applies to these terms since this one term is the same as those two. Okay, so if we go ahead and distribute that minus, let me bring that up a little bit. That's 1/7. This is positive, so we don't have to worry about distributing anything there. So we have log base 7 of 2 plus log base 7 of x plus log base 7 of y to the 4th power minus log base 7 of 11 minus log base 7 of z to the 6th power. All right. Now the only thing left is, if you notice, for those two terms, you have exponents. So you can go ahead and apply the power rule. Excuse me. Okay, so that will give us the final answer of 1/7 times log base 7 of 2 plus log base 7 of x plus, remember that exponent comes down to the front, plus 4 times log base 7 of y minus log base 7 of 11 minus, that exponent comes down to the front, so minus 6 times log base 7 of z. Okay, so that would be your final answer. And again, if you wanted to distribute the 1/7 to each one of those, you could. All right, so they can get a little bit lengthy once you start to expanding them. All right, so if you're still writing, feel free to press pause. But we're going to go ahead and go to another example. Let me bring that down. There we go. Alright, so let's say, for example, we want to expand the logarithm Okay, so let's say if we have log base 3 of the cube root of x squared over 27y to the fourth. All right. Okay, so before we actually get started, we want to remember some of your exponent rules. Well, first thing you want to do is remember that the cube root of x is equal to x to the 1/3 power. And you also want to remember the exponent rule of x to the m power raised to the power of n is equal to x to the m times n. All right. Okay, so remembering those two, that the cube root of x squared can actually just become, you have log base 3 of x squared to the 1/3 power. All over 27y to the fourth. Okay, so if we multiply 2 times 1/3, that'll give us 2 over 3. So that's just log base 3 of x to the 2/3 power all over 27y to the fourth. All right. So now here we see that it's division, so we're going to apply the quotient rule. Okay, slide that up. So if we apply the quotient rule, we have log base 3 of our numerator. So we have log base 3 of x to the 2/3 power minus log base 3 of our denominator, which is 27y to the 4th power. All right. So we see here that we have multiplication. So since we have factors here, we're going to apply the product rule of logarithms. Oh, clean that up a little. There we go. Okay, so once we apply the product rule for logarithms, and again, if you want to apply the power rule here, you could. I'm just kind of waiting to do that all in one step. Okay, we have log base 3 of x to the 2/3 power minus, remember, those two are going to be two different terms. So it's going to be minus log base 3 of 27 plus log base 3 of y to the 4th power. Okay, and again, once we distribute that negative, we end up with log base 3 of x to the 2/3 power minus log base 3 of 27 minus log base 3 of y to the 4th. Okay, if you look at this term here, just that middle term, okay, if we make log base 3 of 27 equal y, okay, so remember b to the power of y equals x, this becomes 3 to the power of y equals 27. Okay, 27 is just 3 times 3 times 3, which is 3 to the third power. So that becomes 3 to the power of y equals 3 to the third power. Okay, so your bases are the same. This can only be true if y is equal to 3. Okay, so this term right here is equal to 3. But we can actually apply the power rule to these two. Okay, so all in all, our final answer will be, bring that 2/3 down to the front. So you have 2 over 3 log base 3 of x minus, remember that just simplifies to become 3, and minus 4 times log base 3 of y. Alright, so hopefully you're starting to see kind of the pattern of how these are being done. Okay, so if you're still writing, by all means, feel free to press pause. But we're going to go ahead and go to one more example, at least expanding. This will be the last example to expand. Okay, so let's say, for example, we want to expand the logarithm. So if we have log base 5 of the cube root of 3x squared over 4y to the third power times z. Okay, now what I want you to do is I want you to press pause and try to solve this one on your own. Alright, so I'm assuming you have pressed pause and you have worked this one out, and now you're just waiting to verify. Okay, now before we do that, of course you want to remember that the cube root of x is just x to the 1/3 power. Okay, so that means log base 5 of the cube root of this will just become log base 5 of 3x squared over 4y to the third z, all to the 1/3 power. Okay, so all we did was take the cube root of all of that and just make all of that to the 1/3 power. Okay, so now we can go ahead and just apply the power rule. Okay, so that means that exponent just comes down to the front. So that gives us 1/3 times log base 5 of 3x squared over 4y to the third power times z. Alright. So we see here, we have division. So we just go ahead and apply the quotient rule of logarithms. Alright. So we have our 1/3 times log base 5 of 3x squared minus log base 5 of 4y to the third power times z. All right. So you can see here we have factors, 3 times x squared, and we have 4 times y to the third times z. So since we have factors inside of there, we just apply the product rule of logarithms. Okay, so once we do that, move that up a little bit, we will end up with 1/3 times, now log base 5 of 3 times x squared will just become log base 5 of 3 plus log base 5 of x squared. Okay, so all we did was get that one term and apply the product rule. So minus, now we're going to get that one term and apply the product rule. So we have log base 5 of 4 plus log base 5 of y to the third power plus, about to put a parenthesis there for some reason, plus log base 5 of z. Okay, so plus log base 5 of z. And that should be a bracket right at the end of that. Kind of ran out of space. Okay, so here this is positive, so we don't have anything to distribute. So we will end up with 1/3 times log base 5 of 3 plus log base 5 of x squared. This minus, remember we can distribute that to all three of those terms. Okay, so we have minus log base 5 of 4 minus log base 5 of y to the third power minus log base 5 of z. Okay, so right now, actually I didn't need this. Oh, yes I did. Yeah, I still had that 1/3 there. Okay, so now we can see here that the only thing left are those exponents. So we have there and there. So we just apply the power rule to those two terms. Okay, so that will give us a final answer of 1/3. Let me clean that up a little bit. Okay, so we have 1/3 times log base 5 of 3 plus that 2 can come down to the front. So we have 2 log base 5 of x minus log base 5 of 4 minus that exponent 3 can come down to the front. So 3 times log base 5 of y minus log base 5 of z. And that would be your final answer. Okay, so that shows us how to expand our logarithm. Alright, so remember, if you're still writing, feel free to press pause. But we're going to go ahead and go to our next example, which is getting long logarithms like this, and now just creating one term. So instead of going from one term to expand it, we're going to go from expanded to one term. Alright, so go on to kind of straighten up my papers here. There we go. Okay, so let's say for this example, we want to write the expression as one logarithm. Okay, so what if we have 1/2 log base b of x minus 2 minus log base b of y plus 3 times log base b of z. All right. Now, I do have a certain set of guidelines that I follow. It's not the only way to do it, but this method really simplifies it a bit. So I'll show you the step-by-step method that I take. And if you want to use a different method, that's perfectly okay. Okay, so the first thing that I like to do is to remove any coefficients by reversing the power rule. Okay, and all that means is that if you have p times log base b of m, instead of getting that exponent and bringing it down, you just get that exponent, take it back up. So that's log base b of m to the power of p. Okay, so all we did was get the power rule and we kind of flipped it around. All right. So any coefficient, which is just the numerical value in front, we're going to move that up as an exponent. So instead of 1/2 times that log base b of x minus 2, we're going to get log base b of x minus 2 to the 1/2 power. Okay, just as easy as that. Minus log base b of y plus, instead of 3 times log base b of z, we have log base b of z to the 3rd power. Okay, so we're just taking what we know, we're kind of reversing it a little bit. Okay, now your second step, we're going from left to right. Look at the plus or minus signs. Okay, like I said, I just do this because it makes it easier for me. But if you have a method that works for you, by all means, feel free. But if we go from left to right, the plus signs means the product rule for logarithms. And the minus sign means the quotient rule. For logarithms. All right, so we're just going to take where we left off, and I'm going to rewrite it. So we have log base b of x minus 2 to the 1/2 power minus log base b of y plus log base b of z to the 3rd power. Going from left to right, Look at those two. Okay. Now you have a minus sign here, which means you're going to apply the quotient rule. Okay, so log base b of x minus 2 to the 1/2 minus log base b of y that's just going to become log base b of x minus 2 to 1/2 power, oh, move that up some, over y. So all you did was get those two terms and combine them using the quotient rule, but in reverse. Because remember, if you have log base b of m divided by log base b of n, that's log base b of m minus n. So all we did was do it backwards. Okay, so plus log base b of z to the 3rd power. Okay, so now we look at our only remaining sign, which is the plus sign. Okay, so these two, you have a plus sign, so we're going to apply the product rule. Okay, so that gives us log base b of x minus 2 to the 1/2 power over y times z to the 3rd power. Okay, so you're just combining the log base of whatever the base is, in this case it's b, and then you're just multiplying those two. Okay, now to simplify that, you could just make it log base b of x minus 2 to the 1/2 power, or if you wanted to, you could make it square root of x minus 2. That's okay. So x minus 2 to the 1/2 power is just square root of x minus 2. So you have square root of x minus 2 over y times z to the 3rd. You can just put that in the numerator. And that would be your simplified one-term answer. All right. Okay, so if you're still writing, by all means, press pause. But we're going to go ahead and go to our next example. Let me bring that paper down. Let me straighten out my papers. There we go. Alright, so let's say, for example, we wanted to write the expression as a single logarithm. Okay, so we have log base 3 of 4 plus log base 3 of x plus 1. Okay, now this one's pretty basic, so what I want you to do is press pause, because it's only one term. It doesn't have multiple terms like the one we just did. Okay, so press pause, and I want you to convert that to a single logarithm. Alright, so I'm assuming you've pressed pause and you've worked this one out. Probably should have did this one first before the other one, but we live and learn. Okay, so we have log base 3 of 4 plus log base 3 of x plus 1. You have the plus sign. Remember, plus means the product rule. So that means you end up with log base 3 of 4 times x plus 1. And if we distribute that 4 inside of there, we have log base 3 of 4x plus 4. Okay, so when you only have two terms, it's pretty straightforward stuff. So when you have those multiple terms, that it can get a little bit tricky. Okay, but remember, as long as you go left to right, this is exactly the same thing. You're just doing it one step at a time. All right, so say we try another example. Okay, so what if we want to write or express as a single logarithm? Okay, so what if we have log of 4 minus log of 25? All right, now what I want you to do is press pause and try to write this one out on your own. Remember to simplify it as much as you can. That's the hint I'm going to give you. So make sure it's simplified as far as it can go. Okay, so go ahead and press pause and work this one out. Alright, so assuming you have pressed pause, we are going to go ahead and solve this one. Okay, so we have log of 4 over log of 25. You have a minus sign, so you're going to apply the quotient rule. Okay, so that gives us log, make that a little bit bigger. Log of 4 over 25. Okay, now with this one, you really can't simplify it any more than that, so you are good. Or if you wanted to write it, remember this, when there's no base, you have a common log of log base 10 of 4 over 25. All right. Now let's say, for example, instead of log base 4 minus log of 4 minus log of 25, let's say express as a single logarithm let's say log of 4 plus log of 25. And see how that one works out. So we're just switching it up a little bit. Same problem. Okay, so you'll see how much of a difference it makes in solving. So I want you to go ahead and press pause and solve that one. Alright, so I'm assuming you've already worked it out. So if you have log of 4 plus log of 25, This one, you have a plus sign. So you're going to use the product rule. Okay. So that's going to give you log of 4 times 25. Okay. Now 4 times 25 is 100. So really that gives us log of 100. Okay. Now remember here, you don't have a base. When there's no base given, your base is automatically assumed to be 10. So this is log base 10 of 100. Okay, now remember when you're converting, you can actually solve this because we're going to rewrite it as log base 10 of 100 equals y. Okay, so we're going to go ahead and convert it. Remember, b to the power of y equals x. So that can be converted to 10 to the power of y equals 100. Okay. And 100 is equal to 10 squared, not y squared. So you have 10 to the power of y is equal to 10 squared. Okay, so your bases are the same. That means this is only true if y is equal to 2. Okay, so this entire thing simplifies to 2. So we know that log of 4 plus log of 25 is equal to 2. And that's our final answer, 2. All right. So again, if you are still writing, feel free to press pause. But we're going to go ahead and go to our next example. Okay, so let's say, get a little more pencil lead there. We wanted to write as a single logarithm. Okay, so if we have log base 9 of 5 plus, say, log base 9 of w times x minus log base 9 of z times y. Okay, now if you remember a few examples back, we had one like this where you had 3 terms and we had the steps. What I want you to do, let me go back and find that one. Okay, remember this is the example that we had. Yep, kind of straighten that out. Okay, so I want you to follow those very same steps on this one. Okay, so go ahead and press pause and solve this one on your own. Now, all right, so I'm assuming you've already pressed pause and worked this one out. So let's go ahead and solve this one. Now we don't have any coefficients here to move up, so you don't have to worry about that. Okay, so you can skip that first step. So now going from left to right, I'm just going to go ahead and rewrite it. So log base 9 of 5 plus log base 9 of w times x minus log base 9 of z times y. Get the first two. That's a plus sign, so we know we're going to use the product rule. So if we combine those two using the product rule, that just becomes log base 9 of 5 times wx. You don't need the dot there, I just kind of put it there. Okay, so we still have minus log base 9 of z times y. Okay, so now we have the minus sign, which means we're going to use the quotient rule for logarithms. Okay, so that means we have log base 9 of 5 times w times x over zy. Okay, so sometimes they can stretch out quite a bit, and sometimes they can be pretty quick to simplify. All right. Okay, so now we're going to look at the change of base formula. So okay, now the reason we have change of base formula is because in a lot of calculators, a lot of your pretty basic or scientific calculators, you only have a base, the option rather, of a base to equal 2 or base to equal 10, or you can convert it to a natural log where the base is equal to e. Okay, but with the change of base formula, let's say if you have log base b of m, you can actually convert that as long as you change your base to another value. Let's say we'll make that a of m over log base a of your base. Okay, but remember, you notice your base has changed. You can make that a equal any value you want to, where let's say a is any positive number except 1. Okay, now this is your change of base formula. It's pretty straightforward. Let's say, for example, let's say if we wanted to find log base 3 of 5 as a quotient of logarithms. Okay, so if we see here, you notice log base 3 of 5, you see that b is equal to 3 and that m is equal to 5. So if we plug it into this formula, we can make that log of any value at all. Let's say we make it log of, let a equal e. And usually letting a equal e makes it a lot easier. So log base e of 5 over log base e of 3. And I'll show you why letting your a equal the value e, because remember e is an actual number. Let me clean that up a little bit. Okay, so let a equal e. Okay, remember log base e log base e of x equals the natural log of x. Okay, so that means log base e of 5 is equal to the natural log of 5. Log base e of 3 is equal to the natural log of 3. And that would be your simplified answer as a quotient of logarithms. Okay. Now again, you could have used that value wherever you like, that base for whatever you like, but using e just makes it so much easier. Now if you wanted an actual value, you plug that into your calculator and they give you a decimal value, but that would be a rounded estimation and not an actual value. This is your actual value. Alright. Okay, so let's go ahead and go to our next example. Let me bring that down here. There we go. Okay, so what if we wanted to write log base 4 of 10 as a quotient of natural logs? Uh-oh. Okay. Quotient of natural logs. Uh-oh, straighten that up a little bit. There we go. Okay, now remember, you change the base formula. Log base b of m, you can actually just make that the natural log of m over the natural log of b. That's if you make your base equal to e. So you can actually just use that. Change of base using natural logs. Okay, so really all you're doing is you're plugging it in. So log base 4 of 10 is just going to equal natural log of 10 over the natural log of 4. All right. Okay, so let's do one more. Let's say if we wanted to approximate log base 6 of 51 to 3 decimal places using the change of base formula. Oops, straighten that out a little bit. There we go. Okay, so we want to approximate that to 3 decimal places using the change of base formula. Okay, so we have log base 6 of 51, and that will equal the natural log of 51 over the natural log of 6. Okay, so if you plug that into your calculator, after rounding it, you will end up with 2.194 as your answer. Okay, so sometimes they want the natural log, sometimes they want the actual decimal answer. It all depends on the question. All right, so let's do one more. And this is so you won't get tricked. Okay, so approximate log base 9 of negative 60 using change of base. Okay. Now, log base 9 of negative 60 one thing you have to remember is that this value in here has to be positive. So whenever the value is negative or less than 0, this natural log is undefined. Okay, so if you try plugging that into a calculator to get the answer, it will come back as undefined. Alright, so hopefully these examples and everything made sense, and I will see you on the next video.